Hello everyone, welcome to another video. Here we'll be discussing questions uh, regarding your IIT and NISER, IISER and NISER tests. That is your IIT and um, uh, NEST. So question will be based on that, and this is a chapter from. This question will be from electromagnetic waves. It's a very important chapter, as one question at least comes from this topic in IIT or NEST or your CUET or even JEE means. Questions surely comes from this chapter, and these are easy questions, so let's not leave these questions. These will be four containing 4 marks in 18 nest or JE, so let's not leave these questions. Okay, so the first question will be magnetic. I assume that you have a strong base in electromagnetic waves. So yeah, so the magnetic field in a plane electromagnetic wave is given by By is equal to this much. Okay, what is the wavelength and frequency of the wave? So what is asked? Where what is the wavelength and frequency of the wave? First question, and write an expression for electric field. Okay. So first of all, electromagnetic wave is given. That is your By is equal to what? 2 into 10⁻⁷ sine. Okay. 0.5 into 10⁻³ x plus 1.5 into 10⁻11 t. All right. So this is your magnetic field, and so what is asked in the question? What is the wavelength and frequency? So what is the formula for wavelength and frequency? You have to remember. First of all, what things are given here? What is the general equation? For example, this is a magnetic field. The B naught sine omega t minus kx. This is the general equation of a suppose a magnetic field wave. Okay, and so if you see, this is your omega, then this is your omega, and this is your k. Okay, this is your k. All right. This is written in form of kx plus omega t. Okay, but it's actually k omega t minus kx. It's okay, it's the same thing. So, but there is just a change in sign of it. We'll discuss that in the later part. So here let's write all, compare these two equations and write everything. So k is equal to 0.5 and 10 to the power 3. K is your what? K is your actually wave vector. K is called wave vector. And what is the formula for K? K is equal to 2 pi by lambda. Okay. What is the lambda? Lambda is the wavelength. So the unit of K will be what? Meter inverse. Okay. So let's write it meter inverse. So if you write this will be 500 meter inverse. Try to do as fast as possible. Okay. Omega. Otherwise there is no point. 1.5 into 10 to the power 11. And what is the unit of omega? That is radian per second we know. Okay. So omega we have k. What is the question? What is the wavelength? Wavelength you can find from here. K is equal to 2 pi by lambda. So 2 pi by lambda, or lambda is equal to 2 pi by k. K is your what? 500 meter inverse. So 2 pi by 500. Okay. If I multiply 2 on both numerator denominator, that will be 4 pi by 1000 to get the decimal quantity. Okay. 4 into 3.14 will be 12.56. Hmm. So 12.56 by 1000. Okay. So that will be 1.256 in 10 to the power minus how much? Minus 4. Okay, so we have to do it really fast. 12.56 is 1.256 into 10 to the 10. Okay, into 10 to the minus 3. So this will be 10 to the minus 2. Sorry. Okay, so this is your lambda meter. Okay, this is your lambda. Next is what? Next is frequency. You have omega. Omega is your angular frequency or angular velocity, and the relation between omega and frequency is what? Nu is equal to 2 pi by omega. So omega is equal to 2 pi nu. No, sorry, omega is equal to 2 pi nu. So nu is equal to omega by 2 pi. Yeah, nu is equal to omega by 2 pi. Nu is equal to omega by 2 pi. So omega is given 1.5 into 10 to the 11 divided by 2 pi, that is 6.28. So if you calculate this, you will get your nu. Okay, you will have the calculators, virtual calculator in Nest or IISER or JE. So no problem calculating all this. Okay, yeah. So the first question is gone. Next is write an expression for the electric field. Okay, how to write an expression for the electric field? So this is a magnetic field in y direction. Magnetic field is in y direction. What is the direction of electric field here? Can you tell me? Oh, sorry, what is the direction of the wave? See, suppose this is a being, by is equal to b naught kx plus omega t. It should have been, suppose kx omega t plus kx. It should have been omega t minus kx. So when it is b naught omega t minus kx, then the direction of the wave, the whole electromagnetic wave, is in the x direction, x cap or I cap. When this is minus, then the direction is I cap, okay, plus I cap. But when this is plus, the direction will be minus I cap. So this is the direction of the whole wave, the whole direction of electromagnetic wave, and this is the direction of by. That means this is j cap. That means j cap is the direction of magnetic field. Direction of magnetic field. Okay. So tell me. So okay, if you see, the direction of the whole wave is actually the cross product of electric field and magnetic field. Okay. This is written as like this: S vector is equal to E cross B. S is a pointing vector. S is called your, you should know this, pointing vector. Pointing vector is actually the direction of the whole wave. That is the direction of k. K is actually the direction of the whole wave. That is a minus I cap. So minus I cap is equal to E vector is how much? E vector is not given. Into B vector is j cap. J cap. So what will I do here so that I will get minus I cap? I cross j is equal to k. J cross k is equal to I. J cross k is equal to I. So if I write k cross j, that will be minus I, isn't it? So the answer, so the direction of electric field will be k cap. At least we got that now. The direction of electric field will be along z direction. Okay. Okay, that's one part is solved. Now what is we have to find? So we have to find what? Because this thing will remain same. So we have to find just E naught now, the amplitude. Okay. So amplitude, how will we calculate it? See, the ratio of amplitude of electric field and magnetic field is the speed of light. You should remember this formula. So 3 into 10 to the power 8 is equal to E naught by B naught. B naught is how much? How much given? B naught is given how much? 2 into 10 to the minus 7. Okay. B naught is given 2 into 10 to the minus 7. So E naught is equal to 6 into 10. Okay. 60. 60 what? Volt per meter. Okay. So E is equal to E naught sine uh, omega t plus kx, whatever that was given in the question. So E naught is a 60 sine and whatever there was, and which direction? Sorry, k cap, huh? K. Okay. Yeah, you write it down. Done this question. Okay. Okay. So let's move to the next question. This one. Please try this question. I'm giving you 2 minutes. Light is an energy flux of 18 watt per centimeter square falls on a non-reflecting surface at normal instance. If the surface has an area of 20 centimeters square, find the average force exerted on the surface during a 30-minute time span. You have to find what average force. Sorry, average force on the surface within during a 30-minute time span. Okay, t 30 minutes. Okay, energy flux. Suppose energy flux is like this: E is equal to 18 watt per centimeter square. That means power by area. Watt per centimeter square, power by area. Falls in non-reflecting surface and normal instance. If the surface has an area of 20 centimeters square. Okay. So find the average force exerted on the surface during a 30-minute time span. Please try. Let's try this question. Energy flux is given, area is given. So please try to think what can we get from these two. From their units also you can guess. What can I get from these two? 30-minute time is given, time span 30 minutes. Average force. Okay, see. Energy flux area. If I this is per centimeter square, this is centimeter square. So if I multiply them, I will get this one only. These two will be cancelled out. So energy into area, energy flux into area, I will get what? Power. Because this is power by area. Power by area into area. I will get what? Power, isn't it? So energy flux is 18 watt per centimeter square into 20 centimeter square. Centimeter square cancelled out. So this is 360 watt. So power is a 360 watt. Alright. Your power is 360 watt. Okay. You have time as t is equal to 30 minutes. That is 30 into 60 seconds. That is 1800 seconds. Okay. Power is 360 watt. So if you have power and time, what can we get? We can get energy, right? We can get energy. So energy E. This E is energy. This E is energy flux. Be careful about that. About how I write it. Okay. Don't get confused. This is our energy only. Energy E is equal to power into time. We know it, right? So power is 360 watt into time is, even if you don't know the formula, you can always play with the units and get it. Okay. So 36 into 18. Hmm. 8, 28, 3, 6, 648, I think. 648, 000 joule. Watt into second is joule, isn't it? Not bad. Hmm. So 64800 joule. Okay, energy is equal to power into time. That is 64800 joule. Okay, so this is the energy. What we need average force. Hmm. We need average force. So what is average force? Okay, I will write average force as, sorry, F. Average force is equal to del P by del T. Del P here is momentum. Okay, momentum, change in momentum by change in time. Or del P by del T is your F average. Okay, so how will I get del P now? Changing momentum, like momentum. How will I get it? See, energy we have. If you remember the formula, this is in the question. It is written falls on a non-reflecting surface at normal incidence. Okay, so when a light falls on it, like this, when the wave falls on it, so there will be momentum transfer. Okay, it's called momentum transfer. So what is the momentum transfer? Momentum transfer is actually del P, and del P is how much? E by C. Okay, energy of the wave divided by speed of light, because of electromagnetic wave, so speed of light. How much we got as E? 648,000. 648,000 divided by 3 into 10 to the power 8. So I will cancel this. 216. So 216,000, that is 10 to the 3. and 10 to the minus 8. So 216 into 10 to the minus 5. Okay, so this is momentum transfer divided by time. So F average is equal to 216 10 to the minus 5 divided by average is how much time? 30 minutes. So 30 into 60. Okay, so 3 into 6 is 18. 18 into 18 into 12 is actually 206. So this is 12. The 0 0 100. So 12 into 10 to the minus 7. Okay, so 1.2 into 10 to the power minus 6. Okay, so 1.2 micronewton. Is it clear? Because 10 to the minus 6 I can write micro. So 1.2 micronewton. Okay, you have to do it really fast. You cannot just do really slowly. Okay, you must be taking only 3 minutes to solve the question. 2 to 3 minutes. That's the question. Please see it once. Energy flux is not energy. You can guess it from its unit. It is watt per centimeter square. This is for a this formula del P is equal to E by C. This is for a non-reflecting surface. Write it down. Non-reflecting surface. If it is given, if it is given for a completely reflecting, perfectly reflecting surface, perfectly reflecting surface, then what will I write? Del P is equal to 2E by C. Okay, there will be a multiplication of 2 here. Alright, let's come to the next question. So the question is calculate the electric magnetic fields produced by the radiation coming from a 100-watt bulb at a distance of 3 meter. Uh, assume the efficiency of the bulb is 25%, sorry, 2.5%, not 25, 2.5%. Okay, and it is a point source. Please try. You have 2 minutes. Calculate the electric magnetic field produced by radiation coming from 100-watt bulb at a distance of 3 meter. Assume that the efficiency of the bulb is 2.5% and it is a point source. Think a bit. See, when this is a bulb, it's a point source. Suppose it's a point source. So, half of the intensity of the light comes from electric field, half of the intensity of light comes from magnetic field. Okay, i.e., intensity of electric field. Okay, it's half of the total intensity. IB also half of the total intensity. Clear? So from that you think a bit. Intensity you'll have to get intensity. Intensity. What is the formula for intensity? Intensity at a distance r from a point source from a point source of power p is what I is equal to P by 4 pi r square. Okay, I is equal to P by 4 pi r square. So you have power, right? 100 divided by 4 pi 3.14 into r square. R square is 9. 3 square is 9. Alright. So if you see, you have to calculate this one. Okay. Whatever get you will get. This is your total intensity. Sorry. Total. This is the total intensity. And assume that the efficiency of the bulb is 2.5%. That means what? That means 2.5 by 100 of the intensity is actually coming out. Okay, that means the efficiency. So suppose I'll just write the value of it. You can calculate the answer. This one will be 0.022 watt per meter square. This is the intensity. So 2.5% of it actually watts. Okay, so no, sorry. This is okay. Wait. So 2.5% of intensity, that is 2.5 by 100 into whatever was there, 100 by 100 by 4 into 3.14 into 9, right? 100 and cancel, and whatever this will be your 0.02. Okay, I told the wrong value then. So this is the intensity that is actually working. Okay. So half of, as I said in the previous one, in the beginning, that half of the intensity will be by electric field, half will be by magnetic field. So IE we can get, right? So IE is equal to I by 2, that is your 0.022 by 2, that is 0.011 watt per meter square, and your IB is equal to again 0.011 watt per meter square. So this is your both the intensities, alright. But the thing is, it has a formula. What is asked in the question? The question is calculate electric and magnetic fields, not electric magnetic field intensity, not the intensity of them. Okay, so we have to find electric magnetic fields. Okay, first of all, IE, it has a formula. If you remember, half epsilon naught E square C. Okay, please remember all these values. Okay, formulas. So just put it. IE is at 0.011. Is equal to half epsilon naught value 8.85 into 10 minus 12. Okay, E square into C is a 3 into 10 to the power 8. Okay, so if you calculate all of this, you will get the value of what? E square. E square is equal to something, and if you take the root over, you will get the value of E. Exactly same way. What is the intensity of magnetic field? Intensity of magnetic field is IB is equal to how much? If you remember, you don't need to even do it. Actually, you will get electric field here, right? Electric field here. So if you know C is equal to E by B, we just discussed it in the previous question. So you just B is equal to E by C. So you just put it here. You'll get it. Okay. This is a electric field. This is not a energy by C is momentum. Okay. This is a electric field. Electric field by C is equal to B. Is it clear? Yeah. Okay. Next question. I will move to the next question. Please read the question yourself. Try. You have 2 3 minutes. You have 2 minutes to try this question out. A plane in electromagnetic wave propagating in the x direction has a wavelength of 5 mm. The electric field is in the y direction and its maximum magnitude is 30 volt per meter. Write suitable equations for the electric and magnetic fields as a function of x and t. So whatever things are given, just write directly. Electromagnetic wave propagating in the x direction. That means your k vector is in the x direction. X cap or I cap, whatever. Okay. Has a wavelength of, wavelength is given 5 millimeter. Okay, the electric field is in the y direction. So electric field is in the y direction, that is j cap, and its maximum magnitude is 30 volt. Okay, so E naught is 30 volt per meter. That is the amplitude of the electric field. Write suitable equations for electric magnetic field as a function of time. So E as a function of time you will write, and B as a function of time you will write. So please try. You have 2 minutes. I've told you the question. Please try. Let's try to find k first. 2 pi by lambda na. K. Simple formula, please. 2 pi by lambda is 5 millimeter. 5 into 10 to minus 3 meter. This is okay. Okay. Electric field E naught sine kx minus omega t, and this is your electric field direction is given j cap. Okay. E naught is given also 30 sine k. K is your 2 pi by 5 into 10 to the minus 3 x minus omega t. Okay. Omega is given? No. Omega is not given. Omega t. J cap. Hmm. And magnetic field will be, if you see, B naught is a what? E naught by C. So 30 by C. C is 3 into 10 to the power 8. So that is 10 by 10 to the power 8. That is 10 to the power minus 7. Okay. 10 to the 1 minus 8. 10 to the minus 7. So B is a what? 10 to the minus 7 say sine, and exactly the same thing here. But what is the direction of, sorry, what is the direction of magnetic field? See, if you see electric field is in which direction? J cap. The vector, the whole electromagnetic wave is in which direction? X direction. Okay, this is the direction of the whole electromagnetic wave, X direction. That means I cap. I can write it also as S vector, pointing vector. So S vector we know is equal to E vector cross B vector. Okay, so J cross something will give me I. So what is this something? Of course, this is K cap. Okay, so the direction of magnetic field is what? K cap. Got it? K cap. Is it clear? Okay, I hope you understood. Oh yeah, one thing. Sorry. Omega can be, we can calculate omega. Omega is equal to, omega by C is equal to K. Okay, this is another formula. Omega by C is equal to, so omega is equal to C K. C is 3 into 10 to the power 8 into 2 pi by lambda, that 5 into 10 to the minus 6. So this is omega. Okay, you can calculate omega here and just put. So please remember these formulas, don't forget them. Omega is equal to C K. Okay. तो डॉकर के ही फोन करिए. Omega is equal to C K. Okay. Okay, next question. Let's come to the next question. Question number 10. A parallel plate capacitor having plate area A and plate separation D is joined by a battery of EMF V, internal resistance R at T is equal to 0. Consider plane surface area A by 2 parallel to the plates situated symmetrically between them. Find the displacement current through the surface as a function of time. Charge on the capacitor as the time T is given by Q is equal to this. Okay. It's a very conceptual question. Please try, you have 3 minutes. It's from capacitor. Mix of capacitance and electromagnetic wave. So yeah, please try. For solving questions of electromagnetic wave, we should have a good basic of electricity and magnetism. So please try. Okay. So charge is how much? Q is equal to CV 1 minus e to the power minus t by tau. Right? Find the displacement current. So, what is the path to find the displacement current? We should know how to calculate, right? We should know step by step how to approach this question, how to go to that path. Okay, displacement current formula. First, write down displacement current ID is equal to epsilon naught d phi e by dt. Flux, electric flux, change of rate of change of electric flux with respect to time into epsilon naught, that is permittivity of free space, is equal to your displacement current. Please write this formula. So we need flux, right? We need phi e. That is our way to calculate it. Phi e. How to calculate phi e again? Okay, how to calculate phi e? Phi e is what? E dot a, electric field into area vector, right? So electric field into area vector. Let's try. Electric field will be E. Area vector is A by 2. So EA by 2. It will be, of course, it will be 0 degree. Okay, no need about, if it is 90, then so everything will be 0. So no need to find it, think about that. So EA by 2. Okay, now EA by 2. A by 2 is there. What is E now again? Okay, this is how you have to approach this. What is E? Okay, can we get E from your charge? No. Okay, C. Plate area, this is a capacitor, this is a plate area is there joined by a battery of interconnections. Okay, so charge is distributed overall over the plate. That means there is a charge distribution. This is a what? Charge distribution, isn't it? This is a charge distribution. So charge distribution over area, that means area charge distribution, that is q by a, isn't it? Sigma is equal to q by a. So sigma is equal to q by a, and that is a cv 1 minus e to the power t minus tau divided by a. Okay, and that's it, divided by a. Sorry, did I forget? Yeah, sigma. And another thing is electric field between the plates of parallel plate capacitor. If you remember, we can now calculate. So E is equal to how much? Electric field. Write down electric field. Electric field between the plates of a parallel plate capacitor. Plates of a parallel plate capacitor. Electric field is equal to what? Sigma by epsilon naught. So sigma is how much? How much I got? CV by A. Epsilon is there here. 1 minus e to the power minus t by tau, isn't it? Yeah. Okay. Now we have electric field. Flux. We have to calculate flux. E into A by 2. Right? So E is CV by epsilon naught A. Sorry. Into 2 into uh, A is there. So CV. Yeah. Let me write it first. Yeah. Into A. A cancelled out. That will be CV by 2 epsilon naught 1 minus e to the power minus t by tau. Yeah, this is a phi. So we needed phi. We just have to do what now? We have to put it here in place of d by dt. So displacement current ID is equal to epsilon naught d phi e by dt. That is epsilon naught d by dt of CV by 2 uh, 2 epsilon naught, no? 2 epsilon naught 1 minus e to the power minus t by tau. So CB by 2 epsilon goes out, CB by 2 because epsilon cancelled out. D by dt of a whole this whole thing will be minus e to the power minus t by tau into minus 1 by tau, isn't it? Minus minus cancelled out. So CB by 2 into e to the power minus t by tau whole divided by tau. Yeah, this is the ID. What is the question again? Okay. When this was through the surface as a function of time, where tau is equal to CR. Okay, let's put tau is equal to C. No problem. CV by 2 e to the power minus t by CR divided by tau CR. CC cancelled out. V by R. So V by 2R e to the power minus t by C. That's it. That's the answer. Is it okay? Is it all right? Okay. C, yeah. C is how much? C is, we know, epsilon naught A by D, right? But A is how much here? A is actually A by 2. No? So epsilon naught A by 2 by D. Epsilon naught A by 2D. So just put it here in place of C. So V by 2R e to the power minus T by epsilon naught AR, and 2D will go up. Okay, this is the answer. This is our displacement current. Very interesting, very good question. It clears up a lot of concepts at the same time. So I hope you understood. You should know how to start approaching, because you have only charge, and from that you have to find displacement current. Don't just take ID is equal to dq by dt. That is normal current. This is the formula of normal current. I is equal to dq by dt, not displacement current. Okay, so first write the formula of ID epsilon naught d phi by dt. From there you find, you try to understand what we need. Phi, we need phi, but we don't have it. So phi is electric field into area vector. We have area vector a by 2. Now electric field, how we can find? This is a parallel plate capacitor, and this is a charge distribution. From there we can get sigma is equal to q by a, and from sigma we can calculate electric field, that is sigma by epsilon naught. Sigma by epsilon naught. Okay. So yeah, so this way we can solve this question. Okay. Okay. Question number, this one. Let's try. About 5% of the power of a 100-watt light bulb. Okay. Mhm. Light bulb is converted to visible radiation. What is the average intensity of visible radiation at a distance of 1 meter from the bulb and distance of 10 meter? Assume that the radiation is emitted isotropically and neglect reflection. Let's try. You have 2 minutes. Okay, did you try? Okay. So about 5% of power of a 100-watt bulb mm, is converted to visible radiation. What is the average intensity of the visible radiation at a distance of 1 meter from the bulb? Okay. So effective power of the bulb is how much? Because only 5% of the power is converted, is useful. So 100 watt. So 5% of 100 watt is 5 watt only. So effective power is 5 watt. You can write effective power. That means the power that is actually useful. That is 5 watt. Okay. 5 watt. All right. Is converted to visible radiation. What is the average intensity of visible radiation at a distance of 1 meter from the bulb? Okay. Average. How will you calculate? This energy will actually get distributed on a sphere, okay, at a distance r from the source, like this. So it will be distributed over a sphere, right? So the area, the surface area of the sphere is how much? 4 pi r square. Right? I have already told this formula. So I intensity is equal to power by surface area, this 4 pi r square. Okay. So this 5 by 4 pi r square. R is how much? The distance. So distance is 1 here. So 4 pi into 1. This is the first answer. 4 pi into 1. This is 5 by 4 pi. Okay. Just calculate it. And what will be the second one? Uh, Intensity form unit is what? Watt per meter square. Okay. Next one is what? 5 by 4 pi into 10 square. That is 100. Simple. Watt per meter square. Easy question. You just have to take care of this one. Okay. Yeah. Next question. This is the last one. Parallel plate capacitor made of circular plates, each of radius r is equal to 6 centimeter, has a capacitance of C is equal to 100 picofarad. So these two are 100 picofarad, and this is 100 picofarad. This is also 100 picofarad. Connected to a 230 volt AC supply. So this is your 230 volt actually, and with an angular frequency omega is equal to 300 radian per second. Okay. What is the RMS value of the conduction current? Hmm. So yeah, let's try. Is conduction current equal to displacement current? Return the amplitude of B at a point 3 centimeter from the axis. Okay. How to get conduction RMS value? IRMS is equal to V by resistance. What is the resistance here? The capacitive resistance. That is capacitive reactance XC. Right. XC is equal to how much? 1 by omega C. Right. XC is equal to 1 by omega C. Just put it V by 1 by omega C. So that is V into omega C. Okay. V is your 230 volt. Omega is your how much? Omega is your 300 into C. C is your how much? 100 pico. Pico means 10 to the minus 12. Okay. Yeah. So if you calculate it, that will be 69 into 10 to the 4 10 to the minus 8. Sorry, 10 to the power minus 7. Okay. 69 10 to the minus 7. And this is ampere. So if I write it 6.9 into 10 to the minus 6 ampere, that is 6.9 microampere. This is IRMS. Is the conduction current equal to the displacement current? Okay. So if you see, uh, ID is the displacement current, I is the conduction current. Okay. What is the formula for ID here in this question? Okay, magnetic field is what? The formula for magnetic field, if you remember. Okay, wait. Amplitude of B. That means amplitude of B we have to find out, that is B naught. Okay. We have to find B naught. So B formula for B is mu naught by 4 pi. Sorry, 2 pi here. ID r by r square. This is the formula. Okay, you have to remember. The ID is a displacement curve, and B RMS is equal to, I can write mu naught by 2 pi I RMS by r square into r. Okay. Yeah. So we just have to substitute all the values. 4 pi into 10 minus 7 divided by 2 pi into IRMS is how much? 6.9 now. We got 6.9 micro. 6.9 into 10 minus 6 divided by r square. R is how much? R is how much? R is radius 6 centimeter. 6 into 10 minus 2. And small r is actually what? Your distance. Distance is how much? 3. 3 centimeter. That is 3 into 10 minus 2. Just put all the values. You will get BRMS. Alright. Yeah. Is it alright? And yeah, what about the second question? Conduction current is always here equal to displacement current. Okay. There is also a proof for it. You can see it in books. So these are some of the questions we discussed today, and I hope you understood. And these are very important concepts we discussed. So please practice more questions. And we'll be solving more questions of upcoming sessions. Okay. Thank you very much for watching.